Hello again. We're going to cover medications expressed as percents and ratios. So you're just going to be working dosage problems, but they're going to give you what's available as a percent and as a ratio. And you need to know what these things are. So we're going to talk about first percents. Okay. For a percent, what they're going to do is they're going to give you a number and a percent symbol. Okay. The number they give you first is the number of grams. That percent is going to be 100 milliliters because percent means out of 100. So if you see the solution available is, let's say, 6%. Okay. What that means for you is that just means, so if the solution is 6%, you need to memorize that the 6 is the number of grams and the percent is the number of 100 milliliters. And again, because percent is out of 100. So to write it out like it would be shown in a dosage problem would be 6 grams per 100 milliliters. Okay, so then you would use this information in your dosage problem. Okay, so those are percents. You also will be seeing ratios. For a ratio, this is not heparin. Okay, so what they're going to do is they're going to give you a number, colon, another number. Or what I usually say, a number, dot, dot, another number. So the first number they're going to give you is the number of grams. The second number they're going to give you is the number of milliliters. Oops, sorry. Let me erase that. Apologies. Right here. It's the number of milliliters. Okay. It's not 100 milliliters for this one. It's just the number of milliliters. That's because for percent, it's very specific because the percent is out of 100. So the percent means 100 milliliters. For your ratio, that means just regular milliliters. So if they gave you 1 dot dot 200, okay, the first number is the number of grams, and the second number is the number of milliliters. So that means 1 gram in 200 milliliters. So if you were looking at it in a dosage problem, it would look like this: 1 gram per 200 milliliters. And this is the information that you would use for your dosage problem. The other ones you'll see are heparin. Okay. Now for heparin, it's always going to be given a 1 first. Now notice up here for the ratio, you can also see there sometimes can be a 1 in the front as well. But heparin will always be a 1 in the front. Now heparin's sort of backwards, okay? So because heparin is measured in units. So this one's sort of backwards. The 1 is the number of milliliters, and for heparin it'll always be per 1 milliliter. And the number they give you is usually very large, and it's in units because heparin is measured in units. So if they give you 1 dot dot 20,000, that means there's 1 milliliter, okay, because it's always a milliliter first, and 20,000 are your units. So to see it like you would in a dosage problem, it makes more sense to say, okay, 20,000 units per milliliter. Okay. So these are ones you just have to memorize. There is no other way around it. So the key part to memorize is for your percent, that the number is the number of grams. The percent symbol means 100 milliliters. If it's a ratio and not heparin, lately we've been seeing epinephrine on our slides. The first number is the number of grams. The second number is the number of milliliters. And for heparin specifically, it's the 1 in the front is the milliliter, and the second number is units. Okay, so here's a problem. So what's ordered, find the amount to administer. What's ordered is 0.2 grams, and you have on hand magnesium sulfate, a 25% solution. So the key here is you have to know what 25% means. So 25 is the number of grams, and the percent is the number of, sorry, not the number of, it is 100 milliliters, because percent means out of 100. So when you're setting up the problem, you just use this information right here to work your problem. So what you have ordered is 0.2, where's my dot? 0.2 grams over what you have on hand is your 25 grams per 100 milliliters. You're going to cancel out the grams. So 0.2 divided by 25 times 100 gives you 0.8 milliliters. Okay? So here's another percentage. So the physician orders lidocaine 25 milligrams subcutaneously now. What you have on hand is, again, is the 5% solution. Calculate the amount to administer. So that's where you have to know what the percent means. So the 5 means the number of grams, and the percent always means 100 milliliters. So now we go to our dosage problem. So what we have on hand, 25 milligrams. What we have ordered, my apologies, 25 milligrams. What we have on hand is 5 grams per 100 milliliters. And if you notice, our units don't match, so we have to convert them. You could change either. Personally, I would change milligrams or grams to milligrams, but you could do the other way. To change grams to milligrams, you're going to multiply by 1,000. So our new problem would be 25 milligrams ordered. What you have on hand now is 5,000 milligrams, because we changed it, times 100 milliliters. And now they match so that you can do your math. So 25 divided by 5,000 times 100 gives me 0.5 milliliters. Okay. So now these are your ratios, and these are the ratios that's not heparin. So what's ordered is 0.02 grams, and what you have on hand is epinephrine 1 to 200 solution. And you have to find out the amount to administer. So again, you need to memorize that since this is not heparin, that the first number is the number of grams, and the second number is the number of milliliters. Okay? So you go to your dosage problem, and you have ordered 0.02 grams. What you have on hand is 1 gram per 200 milliliters. Okay? So you cancel the grams because they match. So 0.02 divided by 1 times 200. And I get 4. And that's in milliliters. Okay? Next one. Okay, we have find the amount to administer. We have 400 grams ordered, and we have a 1 to 500 solution. So the number in the front is the number of grams. The number in the back are the number of milliliters. Okay, so now we do our dosage problem. What's ordered? 400 grams over what's on hand, 1 gram. That's a gram, sorry. Times 500 milliliters. Now again, they match. So since they match, you can cancel the grams. And then you're going to do 400 divided by 1 times 500. Oh, hold on. 400. Oh, that one's not going to work because it's going to be too big. To be honest, what I think it's supposed to be is... this is supposed to be milligrams. Let's see. Let's change this one to milligrams, though. Let's try that. So if I did that, I'd have 400 milligrams over 1 gram times 500 milliliters. But now they don't match. Let's get rid of that. So now they don't match, so we're going to change the milligram to a gram by dividing by 1,000. So now we have 0, it's still going to be high, but 0.4 grams over 1 gram times 500 milliliters. So it's still going to be a large number, but we're just doing it as a math problem for right now. So we have 0.4 divided by 1 times 500, and that's 200. That's not going to be a normal problem. Somehow it's just written incorrectly. Okay? So the problem itself is just written incorrectly. Written incorrectly. So it's not going to make sense, but again, for this one, we just went ahead and did it. So as a problem, it's done correctly. It's just written wrong. Okay, so heparin. So this is the last two slides. The last thing we're talking about is heparin. So what we have ordered is 5,000 units. What you have on hand is 1 to 10,000. Now heparin's backwards, okay? So the one that's in the front is always the number of milliliters. It's always 1 milliliter. And heparin is administered in units. So that's 10,000 units. Okay? So you're going to decide what you're going to administer. So what you have on hand is 5,000 units. Or sorry, what you have ordered. My apologies. So what's ordered over what's on hand times the quantity. So what you have ordered, 5,000. What you have on hand in the same unit, since it's units, you're going to use that 10,000 because they're going to need to match to cancel. Units per 1 milliliter. Cancel units, 5,000 divided by 10,000, and you would get 0.5 milliliters. Okay? The key is that whatever is on top has to go on bottom so that they can cancel. Okay, so another heparin. So you have heparin sodium, 7,500 units. What you have on hand is a solution of heparin 1 to 25,000. Okay. Calculate the amount to administer. So the 1 means the number of grams, and 25,000 is the number of units. I am all over the place. The first number is milliliters. Number 1, the 1 is milliliters. The 2 is in units, the second number. Okay, so first number milliliters, second number units because it's heparin. Okay, what you have ordered goes on top. So 7,500 units. What you have available is 25,000 units per 1 milliliter. So we do 7,500 divided by 25,000, and I get 0.3 milliliters. Now, one of the benefits of heparin is that you don't have to convert because they're both in units. They will always be in units, so they'll match. But the most difficult part is realizing that it's sort of written backwards. Then we get used to the first number is the number of milliliters, and the second number is measured in units. Okay, last thing we want to make sure we cover. So we want to know, are the following two strengths equivalent? If not, which one is larger or smaller? So for this, what you need to do is make them match. It's like if you were ordering fractions, you have to have a common denominator. So for these, what's going to have to match is it's going to have to be in the same metric unit, milligram or gram, and the second number would need to be per milliliter or it could be any other milliliters, but they have to match. So the first thing you want to do is figure out what 0.3% means. Now 0.3%, since it's the percent solution, the 0.3 means the number of grams, and the percent means 100 milliliters, because percent is always out of the 100. So to write it, you get 0.3 grams per 100 milliliters. And the second number we have is 3 milligrams per milliliter. Okay? So the issue is this says gram and this says milligram. So you have to make them match, either both grams or both milligrams, to be able to compare them. I would change the grams myself, because you're just going to multiply by 1,000. So 0.3 times 1,000 would be 300 milligrams per 100 milliliters. Okay. Now we're going to discuss where it still doesn't match, because we're still comparing it to, and I'll actually write it again. So we still, over here we have 3 milligrams per milliliter, and we haven't changed it yet. So again, our issue now is they still don't match. This says 100 milliliter, this says 1 milliliter. So you need to make them match. You either need to change the second one to 100 milliliters or the first one to 1 milliliter. Honestly, it's easier to change the 100. So the point here is that we want to change 100 milliliters to 1 milliliter, okay? Because we want them to match. So to change 100 to 1, right, you do 100 divided by 100 to get to 1, okay? So when you do 100 divided by 100, you get 1. The key is that this is like a fraction. Whatever you do to one side or the top, you have to do to the bottom. And if it helps, you could also think of it this way: 300 milligrams over 100 milliliters. And so you're just simplifying the fractions, okay? So when you do that, 300 divided by 100 gives you 3, right? 3 milligrams. And then you do 100 divided by 100 gives you just the 1 milliliter. So again, what you're doing is comparing this 3 milligram per milliliter, and over here 3 milligram per milliliter. So this lets you know that they are both equivalent. They're the same thing. So again, the key is everything has to match. The metric unit for the base of the medication has to match, and the milliliter numbers have to match. That's the only way you can decide which one's larger or smaller. Okay, I hope this helped. I apologize for the couple of mistakes I made going along. I hope you all have a nice day.